Hello, today we continue working with function block development kit from HoloBlock and building control layer following MVC model view control design pattern. Last time we have implemented a system, a model for it, a conveyor loop where in HMI we can set motor values and see how the workpiece is circulating in that system. So for a workpiece to transition to next conveyor, we need to have a workpiece at the end of corresponding segment, motor running of both conveyors incoming and outgoing. So if we disable any of the motor and then enable, so piece can continue moving. Let's try to think what could be a control problem here. First of all, we have, yes, conveyor 1 as the input. When we press workpiece in button on the HMI, workpiece appears there. But let's introduce workpiece output conveyor, conveyor 2. So from here, workpieces should be leaving the system. And general top control problem, if you like, would be for workpiece to make a certain amount of cycles in this conveyor loop before it can leave the system. Then on the lower level we need to have a control of the motors. It shouldn't be any more signals coming from HMI, but from the controller layer as we would create it. And basic idea for it could be the fact that if a previous conveyor sees that the next conveyor has workpiece, it won't be trying to push it to the next conveyor, as for example it happens currently over here. For instance, I stop motor 2, wait when the workpiece comes on the conveyor 4, and as soon as I enable this conveyor to motor, you will see that in the system will be remaining only one workpiece. Well, because it will be jumping, loading conveyor 2, and this piece, we can say, just disappears. So this is a way how the model helps us to find inconsistencies in terms of pushing things too early to the next conveyor. So yes, we now have only one workpiece circulating. But such cases should be now handled by a controller, that nothing is pushed to the next conveyor until it has finished doing what it's supposed to do. So, but for starting with the controller layer, let's again see that at top level we have a counter of loops, and end user or human can input amount of workpieces. I reshaped now the button here in the sketch of UI to leave and give a space for a new text field. Let me put it here, well, in the sketch of UI, and let me put it like this. And still I would like to try to put some number, but I need to probably set it, yes, in the visible color. So 23, if we say 23, press the button workpiece in, workpiece appears and makes 23 loops until it's removed from conveyor 2. And for this monitoring purpose of how many loops we have, let's have another text field, output text, here in the motor 2 for conveyor 2. Well, okay, it's a bit different arrangement. You see, motor 2 is here as it's a last conveyor in the loop, so it's arranged here. So let it be in our HMI here. Okay, this is what we would like to do for workpiece calculations. And again, for the motor, there won't be any more checkboxes like we have at the moment, but we will have output Boolean LEDs, or well, those circles showing us the status of the motor. So for pure monitoring reasons, we are not anymore controlling or setting values from HMI, but just monitoring. So, and it could be some, well, other color to highlight if, for instance, motor is activated. And again, for lower level, it's important to keep only those motors running, and only at that time when there is actual workpiece running on the conveyor or transferred to the next conveyor. In the other times, conveyor motors should be off. So the logic is that you do not need to utilize extra resources while running motors all the time. So, well, preserving also energy, and motors won't be wearing too fast. You would be just stopping it if you do not need to run motor conveyor to transfer the workpiece. Okay, that's generally control idea what we will try now to transfer this sketch to actual system. I'm going back to our well, system, and let me stop currently running system. Okay, it has been stopped, and let me do one thing first. Let me try. I am renaming the system, what we will be extending. I'm adding a prefix letter C to denote that control part would be added, and I'm going to save it as XML file. So it's here. Well, if I try to run it, well, we will see again very same system with the motors, yes, then with the workpieces arriving. Yeah, but let's start updating HMI to match our design sketch we did here. So we need to add two text fields, one input, another output, to show counter value. And now let's jump to the future when our CNV loop MVC system is already finished and operational. How it works, I will try to run it now. And as I started, you see our conveyor loop appears and input field for the workpiece in amount of loops our workpiece must make, and here next to the motor 2 or conveyor 2 or output place for the system a counter, how many loops were done by a workpiece. Okay, let me try to put some number, let's say 5. Okay, I need to press enter after it, and as I press in workpiece in, we see motors start to be activated. And what is important, that at the time only 2 motors are running. We are not consuming resources, which is, well, activating the motors if we do not need it. So only connected conveyor motors running for transferring a workpiece from one conveyor to another. And as we see this workpiece circulating in the system here, a counter updates. Now it will be 4, yes, and now it goes for the last loop. When it arrives here, it should be removed. Let's see. Yes, it disappeared. We have reached ordered amount of loops. So this is very general top, let's say, level of control for this simple system. But on the lower level, we are capable to control motors. As you can see, UI has been changed. There are no any more checkboxes, but the LEDs, which tells that there are, well, motors running. We can try to put several workpieces. Well, though a number is 5, it would be immediately removed. What I can also illustrate with this system, if I put well, number large enough and start to place workpieces inside of our system, sooner or later we can make this system stuck because all motor off, because well, each conveyor belt is occupied with workpiece, and each workpiece waits when the next belt will be free. So we are blocked. And well, since last time, we can think why it stops in this particular position. We can think that sensors detecting the presence of workpiece located in about, well, let's say 70% of conveyor belt. So when the workpiece is loaded, it's stopped at the 70%. It's not pushed to the edge of a system. So in fact, since workpiece has certain, well, occupies certain room on conveyor segment, a sensor could be activated, let's say, from 70 to 90%, well, X is the position of workpiece of the belt. So having this assumption, this system was implemented. And now let's take a look, going now in the back order, what has been done for making it operational. I'm switching back. You see there is a well, our 4 layers here, but I will start from HMI. By the way, this system is downloadable from a web address. This project available in the description for this video, so you can download and try this system yourself with function blocks development kit, for example. So HMI was changed. How it was changed for the conveyor 1? Well, in the following way. For reporting motor values, we have out bool block, which is taken from HMI library folder out bool, and it reads the value of conveyor motor val value, which is at this moment is controlled, well, or set at the control layer. Then there is also this input for loops count. It's in any of unsigned integer type. We can insert, and this out value is sent to the controller. In particular, as we will see in the moment, to the second segment of controller. So here, so where we need to take the workpiece out, there we have a control that we have counted the right amount of loops. In addition, what we can see here, the button, same button, workpiece in. When we press it, we see there is an e-split block from events library that is connected to 2 publisher blocks. One is setting scene v val. It's, well, from the previous videos, a block going to the model layer. So we insert in our physical vault, in our controlled object, which is at the moment represented with the model, a workpiece. So that's why we need to, well, publish signal there. But then also we need to provide a signal to the controller that we can insert, we have inserted a workpiece. So this button, what we have in our UI, can be seen as, well, a button on some operator panel. For example, when operator puts a workpiece in the beginning in this, well, trivial system and presses that button on the pallet, so controller receives a signal thanks to this start loading scene v1 block and start its operation. So it's since it's having a button and loop count unsigned integer field, it's quite complex, well, network comparing to some other HMIs, like, for example, conveyor free HMI, which is just a motor. A single motor comes here out bool, and publisher block again coming from the controller layer. Then comes scene v4, conveyor 4, same picture, and a little bit more complex structure for conveyor 2, because it has a field to count the current amount of loops we have made, and therefore, well, besides the motor value, we have here loops value published to out any block, another block from HMI library. Okay, so how looks our controllers blocks again? Well, it's composed as seen in the tree and here of 4 panel resources, and how they were developed. First started with one resource, ensuring that its network is more or less what is supposed to do, like running motors when it should controlling motor. We can copy it. I was copying it another 3 times and just mostly editing indexes for the blocks inside of those resources. So let's open up one of those controllers, controller 1. You can see this is quite, well, big network, and this is why also good to use composite function blocks in order to have a, well, your network readable. Maybe I can admit this network is not very readable, but still it was important, that it's good also example to develop just with some basic blocks to highlight major parts what have to be interconnected for controlling our system. And one of the central, we can see here different areas, I would say call them, and central area are those SR set reset triggers available from events library. And yes, for example, this block is here, yes, and this represents the states. So I have modeled the state of a conveyor belt to be in 3 possible states: unloading, loading, and loaded. So when a pallet comes, or workpiece comes to the conveyor, it becomes in the loading state. So, well, here is start loading subscription block. It comes to the loading state. Then with the time as it's advanced, it comes to the loaded state, and then finally conveyor goes to the unloading state. So oscillating or moving between those 3 states represented with the SR trigger. But then after you have those state variables, or, well, basically these output state outputs, you need to develop certain logic, and this could be divided again for input logic and output logic. Let's first look for the output logic, which is coming here. And for the output logic, we controlling a motor for given conveyor, and the motor should be running whether when we are loading our conveyor belt, our conveyor segment, or unloading it. So, and it shouldn't run if we have been and if we are in the loaded state. So loaded state once again can be seen as a waiting state. Basically now each conveyor segment in the loaded state, and motor is not running in this case because we are waiting when the next conveyor segment becomes free, so the loaded state. And therefore there is this negation not. So if we are in the if we are not in the loaded state, in other words, then this AND block will give true, and if we are in any of those unloading and loading states, and we will be publishing true value, in this case true value, for our motor. Otherwise we will be publishing false value, so conveyor belts will be stopped, motors not running, as you can see here. So this is basically output logic. And if you think for a moment, well, it's not too complicated. It's just one OR block, one NOT block, negation, and one AND block. What may add some additional, well, connections, and you see here merge block. As we have to integrate several events flows, well, it's recommended or required actually by standard to use a merge block to integrate event flow between the blocks. So that's output logic for the motor. Then what is the input logic? For the input logic, yes, besides using this event signaling, and we are working with event-driven architecture, signaling a loading of a corresponding conveyor, and if I jump now for the conveyor 3, you can see that it's just changes of indexes, right? So here, so. And for conveyor 1, it's a loading state as we get corresponding event. And here I would like to speak about this portion of the network is coming at the moment from a model layer. At the model layer, each conveyor has a publisher, and first data, send data for the publisher is position, right? So this position is coming to the controller layer in this case. It's a bit matter of taste, so we could, well, put extra effort on the model layer and just deliver on this, on control layer, a Boolean value with the publisher. But in this case, I just use the same well, subscription block for model, and I'm using just RD1, this position data. But as I was trying to explain, we should set the sensor when we are in between 70 to 90, 90 pixels, or yes, moving on the conveyor, 90%, 70 to 90% of conveyor displacement. Okay, for this, one basic function block was created called CNV sensor, which is also downloadable and comes in the same package described in the video, well, annotation below. Okay, if I go to this block, how it works, it has very simple execution control chart that once we get request event, execute request event and generate confirmation request algorithm and generate confirmation event. So just a loop. But first, again, it has uint position input and sensor value is a Boolean. So very basic block. Event comes, trigger latches position, solves rec algorithm, and generate Boolean output depending what is rec algorithm. Let's see it. It's written in structured text programming language, and it's just if-else block where we check exactly if our position, pos input for the block, is greater or equal to 70 and less than 90. So in other words, exactly, well, this expression on the slide. So to show when the workpiece is detected by the sensor of corresponding conveyor segment. So if value, if we're in this range, sensor value is true, otherwise else sensor value is false. So simple like this. So for your information, if you would like to create your own function block, you need to set up compiler path. Compiler path is set up in FBDK folder in editor ini file, and then additionally you may want to alter in compiler info package information fbrt, well, student in this case, so that block appears in the student folder. then saving it there. And additionally, what else? When saving, you need to select both XML and Java for the block to be compiled. And I have to also say that you can start creating a basic block by going to the template folder, library, and there you should be able to find basic block in default installation of FBDK. So that's that's how you work with it, and this is the block representing our sensor position, giving true value. Okay, then another block, we would like to detect a rising edge, so ER trick. This block comes from the events folder, and as sensor goes up, we are having a trigger to reset loading state, so, and at the same time set loaded state. So we resetting loading state and setting loading state. So that's how input logic work partially to have change of the state. Then there is another portion. Again, there was a portion for representing the state of a system, conveyor 1, control states. We modeled for this example output logic, input logic, and plus I would call it integration logic block. So what is this integration logic? Is the logic to tell when we are allowed to load next conveyor. For conveyor 1, it's conveyor 3. So if we go from conveyor 1 to conveyor 3, so we have to have this fourth element which is integration logic. And again, it's a matter a bit of taste, how you integrate. Well, there could be many solutions. You can use pull or push approach. In this case, we can see, we can call it as push approach in the sense that conveyor 1 decides when to load conveyor 3. But one can imagine and implement a solution where given conveyor would be deciding when to pull from the previous one. So in any case, this is the integration logic, either for push or pull, that have to be implemented. So we are pushing to conveyor 3 by sending event. And how to push, or what is the logic for integration? Well, first of all, there are two node blocks that checking a sensor for the next conveyor, and if let me check myself. Yes, if conveyor next conveyor is currently loading, so it's another block, subscription block to the next conveyor to see whether the next conveyor is loading. So at the same level, we see for conveyor 1 would be telling to its previous conveyor, which is conveyor 2, if it's being loading. But what is again loading or a sensor detection? So it's basically for controller the only way to know if unloading process can start for current conveyor, because sensor is something that you can read. Well, here it is, and loading is some state variable. So during the loading part, you do not have any visibility, right? Loading of the next conveyor, you don't have any sensors, so therefore you are storing this loading status and manage it at the controller level. So workpiece is somewhere in between two sensors, which actually allow us to actually see workpiece. So, and yes, both are negated, so we are not loading next conveyor, so, and we are also not detecting any workpiece at the next conveyor. And it comes and block joined together that we are currently having workpiece, which means we are in the loaded state for given conveyor having a workpiece, and again a rising edge just to trigger it once, and we have several split events, partially resetting the states of the given conveyor and setting the state of the next conveyor. Start loading CNV3. So again, you can see well, somewhat a pattern. Start loading CNV3, start loading CNV1. If I'll go to CNV3, I will see in the upper left corner start loading CNV3, and you may guess start loading CNV4 comes at the lower right corner, I mean block. So structure pattern is the same, and I mean if you switch, well, you see that well, very maybe same looking blocks. Okay, then once again to repeat: states, output logic, input logic, and integration logic. 4 elements to be implemented. Conveyor 4, same idea. Start loading CNV2, start loading CNV4, same states for that conveyor. A little bit more complicated structure comes for CNV2. Why is that? Because this is output place, and we have to control whether and if we are ready to remove a workpiece. At given example, well, high-level control looks like this, so that we can command to input a workpiece to our system, but it would be circulating so many cycles as well as we input, and then we can increase amount again with this window. But as soon as we have reached this limit, matching together whatever workpiece we put, it just makes one cycle and immediately removed. So somehow high level logic for this simple system. Okay, but for conveyor 2, once again, we need to implement remove well, logic to remove workpieces having a right amount of loops. And you can find in general somewhat similar looking arrangement of blocks with small additions, and actually at the lowest part a logic to handle loops count. This is subscription block coming from HMI conveyor 1. So here is our loop count publisher 1 loop count. Value comes once again here, loop count, and it's fed in to the subtract block. So because numbering starts from 0 and up, so we just subtract -1 from whatever we enter, just to have a right amount of loops. Then there is a greater than block that we also use for comparing the things, so that we have reached the value, so that our counter, so we use for this add block fb add uint, and we see here, we may see a self loop, so it's basically increment by 1, so a self loop each time, increment by 1, and this value goes to imp what1 of greater than, and compared with in 2. So if we in 1 becomes greater than in 2, this Boolean output becomes true, and another block from events library commands us, if it's 1, Boolean true value 1, this event is generated to unload conveyor to command it to unload. And additionally, what can be said here, we have loops val publisher block that goes back to conveyor 2, loops val subscription here to see amount of loops we have made over here. So well, something to study and try yourself running. Again, I'm sure that this logic could be a bit optimized, like for instance some repetitive parts joined together, like for instance state and motor logic could be easily one block, just having set reset inputs events for different states on top. So another composite block. Here possible optimization can be, then another optimization could be possibly on the sensor part, and here for integration logic is repeated in other potentially composite blocks. So for controller to look a little bit well, cleaner. So maybe 10 blocks is a good number to have on a single screen for, well, to manage to be able to trace all the connections. But I should also comment some additional things. Yes, that if in comparison to previous time, also CNV2 model has got some minor changes. So there is this explicit unload event coming and to the conveyor, and it can be coming as before, like on the old models. I mean, previous just model view implementation from CNV merge model, and this split block here is the same part, but we have to provide unload event from two sources. Again, why is that? Because pallet can be removed, or workpiece can be removed from here, and this is some event happening in, well, our environment. In other implementation, we can introduce potentially a button, or possibly a button, actually the same pattern, workpiece out, and we can have workpiece waiting to be removed by the human, means interaction with the button. Maybe it could be another way to improve this system, to add workpiece out button explicitly. So it's actually now somehow managed by controller unload workpiece, automatic unload. But if we would like to have operator unload, we can have yet another button here. In addition, there is one interesting block, E-cell unit from selection library. Let me check. Yeah, select here. Many selection blocks, and one particular thing, I had to update a model that depends when we have a conveyor rendering the view, okay, position is being updated, this event. However, when we output remove the pallet, this position value may remain the same as where we have ordered it, 70, let's say. It's not reset. If unload event is coming, it's not being reset, and therefore corresponding sensor may think that pallet is still present. So here is a small hack implemented on the model level, a selector block to put 0. So 0% if and as there are no any pallet in principle, or workpiece in principle. So we have seen in those series of videos creation of a simple conveyor loop system that implements basic control of its resources, conveyors, composed of sensors installed about 70% in the conveyor length. Then we are controlling here a motor, and only motors that have to be working are running. So, and motors continuing running for loading and unloading operations of each conveyor segment. We have seen that HMI was gradually improved, starting possibly with some checkboxes, resulting into the LEDs showing the status of the motors and placing a workpiece in color. Now, as we have a control implemented, we can also see, as was this stuck problem, when I run it previous time, that controller knows that it won't be pushing the workpiece to the next conveyor when it's occupied. So all of these conditions have been taken into account and implemented in the system. The next step could be removal of the model and connecting it to the actual physical interface. Whole idea of MVC pattern can be seen as of validating correct operation of the controller, also possible development of appropriate HMI for it. And once again, you can download this system from the link specified in this video description. Try it yourself, check basic function block created, which is for example this conveyor sensor block. Then we have seen also composite function block created, which is this conveyor merge block with 3 Boolean inputs and then network of blocks in comparison to some algorithms that we implement here for basic blocks. So please, if you get any questions, also feel free to comment, ask, and I hope you enjoyed watching these videos, and till the next time.